The focus for tonight really is data pre-processing. And I can't tell you how important that is, because if you get into working in real work in data science and data analytics, you'll find that about 80% of your work is going to deal with data pre-processing, which is preparing data for the analysis. This second one right here, the third one, is the Python code. And the reason this is important is because it's very similar to what you're going to be doing in your homework assignment here. So if I open up the homework assignment, you'll see it's already there. There's the assignment. Here's the data dictionary. Here's the data. And there's the upload. This data is interesting. It's actual fracking data, from oil wells in West Texas, where they monitor the settings for the oil well. And at the same time, then they calculated the cumulative production over a year, the first year of operation. So the idea here with this data is to try to figure out if you can predict what the first year of production is going to be based upon the characteristics of the well. This is immensely important because the oil companies are always looking at the question is, what oil well am I going to lease this week? Or it needs to be important before the virus thing. It will be important again someday. So this model you're developing helps them to answer the question, which lease am I going to pay for? And we're talking millions of dollars here. So this is not a trivial thing. Now this one is Python code. And this is the one you should really give a hand with. Try to run this. Okay, now this is a little complicated. So that's why I gave you the code. All right, now this is Spider. I hope on the left-hand side, and I will make this, that's the file. Okay, so you can download that file. Click on that file, and it'll come down as a py file, right? Python file. So now this Python file is a lot bigger than the one from last week, right? We're importing or bringing in libraries. Let me talk about the important libraries here. Line number 11 and 12 is called stats model. Well, the first two I already talked about, NumPy and Pandas. Those guys are golden. We have to have that in here every program. It'll start with Pandas and NumPy. The next two lines, sometimes no, sometimes yes. These are stats model. This is the stats models library. In the Python world, this is kind of like R, okay? What you see in the stats models library is very similar to what you see in R. This thing lets you just plot everything you can imagine, including the graphics, so you can produce graphics instead of just, number things. So it's called Matplotlib. We're going to do that here in this code. You'll see it coming down. And then here's my code. Advanced Analytics replace RIE, right? And then here's a new one. Advanced Analytics period regression. Import linreg for linear regression and stepwise, comma, stepwise, right? So for stepwise, I send it in the data frame, the target number, a name rather. Tell it that we're doing linear instead of logistic. I want you to use stepwise feature selection. And here are the input-output criteria for stepwise. P-value of 0.1 will get you in, and a p-value greater than 0.1 will get you out. Okay. You see this area that says PLT? Okay, now you're getting into the plot domain. First of all, I just plot the observed versus the predicted. That's these little statements here. And then I I thought it was going to really impress you, right? So all this stuff here is a panel plot. 3 plots in one panel. Okay. And you can Google Matplotlib, and there you'll get a ton of documentation on this. And then there's some printing going on and a whole bunch of stuff. All right. So I ran this, and I want to show you, I think I can show you on the right-hand side here what you can expect to get. Okay, let's see. What you're going to do is it'll fit the model using stepwise, and then it's going to do a residual analysis in terms of the plot. Here you'll see the actual fit using stats models. These are the coefficients, these are the variables, the t-values and so forth and so on. AIC and BIC are right over here. R squared is up here, 0.855 in this particular case.
When I first started this program, I was a little intimidated. That's why I knew coming to Texas A&M University for their Master's in Analytics program was the one for me. Being a distance student, I didn't expect to get some of the care and support as I did. This program really brought me in and involved me much more so than I ever have in any other program.
This program really helped me turn me into a well-rounded analytical professional.